Hi, I'm here to do problem number 22 in chapter 29. So what it asks us to do is find the radii of equal potential surfaces at various v's away from a point charge of 25 nanocoulombs, which is at the origin. Now, I have decided to start off with number B, just kind of draw something for everyone to relate to. Here's our x-axis, here's our y-axis, bam. And here's our charge at the origin, and what we're trying to find is those equal potential surfaces which have equal voltages away from that charge. Now, since it's a positive charge, the closer you get to it, the higher your electrical potential. So we're expecting the higher voltages to have a smaller radii. Now let's start with our calculations. We know that U is equal to Q E S, S being a distance, and we can also write that as E is equal to K QQR. Now, voltage is equal to VQ, voltage times charge, is equal to electrical potential. And so we can rewrite this as V is equal to U over Q, and therefore V is equal to KQ over R. And this is the equation we're going to be using for this problem. Now, we want to solve R in respect to KQ and V. So what we do is isolate R by bringing R over, so VR is equal to KQ. Oop, there we go. And then divide KQ by V, we get R is equal to KQ divided by V. So we'll use that equation for this problem since we're solving for the radius. So coming back over here, let's plug in our values for the first voltage of 1000 volts. Our radius is equal to K, which is equivalent to 9 times 10 to the 9th, times the charge, which is 25 nanocoulombs, so 25 times 10 to the 9th, divided by our voltage, which for the first one is 1000 volts. Now plug that into your calculator, and you should get about 0.225 meters, which is roughly 0.23 meters. And then you can see to calculate the other radii is this, going back to this equation here, we just plug in the various voltages under here. So the next one would be 2000, then 3000, then 4000. And you should get for each one, so 0.23 meters for the 1000 volts. 2000 volts will be 0.113 meters. 3000 volts will be at 0.075 meters. And 4000 volts should be 0.56 meters. Seeing as the electrical field points away, and we talked about being closer to the particle, you'll have a higher electrical potential when you're closer to that particle. This has kind of been proven right here. As you can see, as the radii decreases, or as you get closer to the charge, the voltage does increase. And then just sketching our various surfaces, like for example, we could consider this the 1000 volt surface, which is 0.23 meters away. So this radius here would be 0.23 meters. And as you get closer, the rings would just go like that. And of course, since it's a point charge, and we're only dependent on the radius, these equal potential surfaces look like perfect circles right around the charge. Alright, perfect. There's my solution.